Hello, Algebra 1 students. Welcome to your first lesson in the functions mini topic. This is part 1. We're going to talk about translations of functions. Now, we've done this throughout the year. We did this with linear functions. We did this with exponential. I think we did it with the quadratic, right? So we can generalize this to any equation, any function. So here's going to be our general formula. So y equals a times f parentheses x minus h plus k. So f of x is our original function, our parent function. So in this section, we're going to focus on the translations, and those two variables are the h and the k. Remember that h stands for horizontal. It's so nice, right? It's the horizontal translation, which is your left and right. But remember, it always is opposite of what it says, right? So remember that. And then the k here is your vertical translation, and you always go the same way that it says. So positive means up and negative means down, right? Up and down. Now in this section, we're going to ignore our a value. It should not be there. Our shape should not change. But remember that a controls the direction and also the width. Okay, so this is our goal formula for the day. All right, so example 1, it says sketch the graph of the function g of x equals x squared plus 8. So this is going to be a translation from our parent function of g of x equals x squared. Right, now I'm going to write the general formula a x minus h squared plus k, right? So this is our general formula. Before I do this, so let me graph just the parent function. Let me graph f of x equals x squared, right? So f of x equals x squared. So it starts at the origin, 0, 0, and then it has the point 1, 1, and then 2, 4, right? And that's the right side of the graph. Remember that there is this axis of symmetry running through the middle of it. So you have negative 1, 1 and negative 2, 4 also on that graph. And there's going to be your parent function, right? That is f of x equals x squared, right? It's good to remember what that picture looks like. I know we have graphing calculators, but again, you should know what x squared graph looks like. So now, if you compare the g of x to this general formula, the a is not there. There's nothing in front of x squared. The h is not there. There's no parentheses, but the k is there. 8 is your k. So what that means is you're going to translate up 8 units. Because the k is your vertical translation, and you're going to translate up. Which means this vertex at 0, 0 is now going to go up 1, 2, 3, 4, 5, 6, 7, 8. And now your vertex is the point 0, 8. And now the other points move up as well. So this point right here goes up 1, 2, 3, 4, 5, 6, 7, 8. And again, the axis of symmetry is not moving because we're not shifting left to right. So this point is over here. And again, we can just graph it like so. And that's our function g of x. Now I do want to continue our talk on domain and range. So for a quadratic, for any quadratic, because you have it, I'll do this in green maybe. Because you have arrows here and here, arrow on the left, arrow on the right, this domain is all real numbers. All real numbers. Remember our interval notation, that'd be negative infinity to infinity with parentheses. Now the range is a different story because both of these arrows are pointing up, which means we're going to have a bottom value or a minimum. So that vertex is acting as our minimum. And its minimum value is the y value, which would be 8. So our y's must be greater than or equal to 8 because they all go above that point. That would be a bracket starting at 8 and then comma to positive infinity. And again, we always put a parenthesis around the infinities. So there'd be your domain and range in interval and inequality notation. Okay, next. All right, we're going to sketch this graph now. So again, you can see a lot of this is about graph sketching. So this is a square root function. So let's go ahead and graph the original square root function. So y equals the square root of x. So remember that that function starts at 0, 0. There are no negative numbers. 1 goes there. And now remember, we're going to take the square roots. So the next perfect square after 1 is 4. So if you plug 4 in for x, 1, 2, 3, 4, the square root of 4 is 2, 1, 2 is your y, right? You could also do 9. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the square root of 9 is 3, 1, 2, 3, if you want a very, very accurate graph. Okay, so there's your function y equals the square root of x. So now let's apply the translation rules. So we're going to do f of x equals a square root of x minus h plus k. All right, so you can see how I can generalize that a, h, and k formula to whatever function we're given, right? Now the a is not there. There is an h value, right? But notice it says positive 9. That means this must be a negative 9. So your h value is actually going to be a negative 9. And then your k value is not there. So because your h value is a negative 9, that's going to translate you 9 units left. Translate left 9 units. Remember, you think that this is positive 9, which means to the right 9, but you always go opposite of what your h says because of this double negative right here. So now your starting point, which was at 0, 0, is now going to go to the left 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now that's the point negative 9, 0. So there's your starting point. Okay, and now all these points move 9 left. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'll move this one as well. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's good enough for me. And there's a picture of your function f of x. Domain and range. So neither of them are all real numbers because of the fact you have a starting point and only one arrow. So let's talk about domain. So you are going off to the right. So our first x value is this starting point at negative 9. So we're going to start at negative 9, but we have to be anything greater than negative 9. So inequality-wise, x is greater than or equal to negative 9. Interval-wise, that'd be a bracket around the negative 9 to infinity with a parenthesis because you're going off to the far right. Okay, range-wise, this arrow is going up. So again, you have a low y value, and again, the y value is the y of the starting point, 0. So in this case, our y's must be greater than or equal to 0 because it's a solid dot. Again, that'd be a bracket around 0 going to positive infinity. And there'd be your domain and range. So for a square root function, the domain is not all real numbers. Keep that in mind. All right, and let's do one more here. So let's clear that. Last one here. So now we're given a translation of a function, f of x equals the square root of, or the absolute value of x, and we want to write the function for the graph. So general formula, right? F of x equals a x minus h plus k. So again, in this section, I'm telling you that there's probably not going to be an a value, but we're going to talk about that in a second here. So let's find our h and our k. Now, where is the original graph at? Well, the original graph starts at 0, 0, right? And it's this V shape like this. Right, it goes up 1, right 1, up 2. Remember that this a value is a 1. That's like the slope, 1 over 1. Up 1, right 1. And then there is some symmetry. So our vertex went 1, 2, 3, 4 to the left. It went left 4. That means that your h value is a negative 4. Now, it did not go up or down, so your k value is a 0. So the vertex of this graph is negative 4, 0. So you can plug that in, right? So f of, we should really call this g of x. I'm sorry. Yeah, so let's call this g of x. So g of x just being g of x equals, so I don't know my a value, x minus a negative 4, close the absolute value, and then plus 0. And now to find the a value, remember the a value is just the slope, but if you look here, starting at the vertex, it's still up 1, right 1, up 1, right 1. So the a value is still a 1, so it's not going to change. So your final answer is g of x equals the absolute value, this minus becomes plus x plus 4, close the absolute value, and you don't need the plus 0. And that's your final answer. Domain here, so there should be arrows there and there. So you have arrows on the far left, arrows on the far right. So this domain is all real numbers, all real numbers. That is from negative infinity to infinity. And then for the range, the arrows do both go up. So the vertex is your minimum value. Again, the vertex is at negative 4 to 0. It is the y value for the range. So your bottommost y value is 0, and then y must be everything greater than 0. That means we start at 0 with a bracket, and we go to infinity. And there's your domain range. And there's your first part of functions, talking about translations. Good luck on the practice.